Morning all. Today's topic is hydrology and hydrologic cycle. Hydrology is a culmination of basically two words, that is hydro plus logy. Hydro basically means the water and logy basically means the science. So including these two words, hydrology is the science of water occurrence and reoccurrence onto the surface and below the surface. Now the sources of water basically division is there. Water is present in oceans at 97.25%, ice caps and glaciers are 2.05%, groundwater exists in 0.68%, lakes 0.01%, soil moisture is 0.005%, atmosphere is 0.001%, and streams and river, the water is basically the quantity is very low, that is 0.0001%. So basically the water is present at around 1%, which can be used by the human beings. Now, hydrology is a multidisciplinary subject that deals with the occurrence, circulation, and distribution of water onto the earth. Heading towards the application of hydrology, hydrology is applied to major civil engineering projects such as irrigation schemes, dams and hydroelectric power projects, and water supply projects. So, we can be able to use the subject of hydrology in terms of finding out different irrigation schemes, different dam and hydroelectric power plant and projects, and water supply projects. Now, the scope of hydrology is not limited to any one of the stream. It is basically outskirts and outsmarts the different streams as the subjects. The study of hydrology helps us to know the maximum probable flood that may occur at a given site and its frequency. This is required for the safe design of drains and culverts, dams and reservoirs, channels and other flood control structures. The scope of hydrology is also extended towards the water yield from a basin, its occurrence, quality and frequency. This is necessary for the design of dams, municipal water supply, water power, irrigation and river navigations, etc. The groundwater development for which a knowledge of hydrogeology of the area, that is of the formation soil, recharge facility like streams and reservoirs, rainfall patterns, climate, cropping patterns, etc. are required, and finally the maximum intensity of storm and its frequency for the design of the drainage project in the specific area and domain. Heading towards the hydrologic cycle, basically there are numerous components which are involved in the hydrologic cycle. Few of them we are going to study in the coming slides. Now the journey of water from the ocean to atmosphere and back to the earth, and ultimately going towards the ocean through the process of evaporation, precipitation, percolation, runoff and return to the ocean is called as the hydrologic cycle. As you can see from the diagram itself, the water is going to get evaporated from the oceans, going to form the clouds with the help of the sun, and going to condense from the clouds and come down onto the surface as rainfall. As well as when the water is going to come onto the surface, it is going to get divided into two parts. But first part is the runoff and the next part is the infiltration as well as the deep percolation. Ultimately both the water are going to meet to the ocean. Now the different components of the hydrological cycles are precipitation, evaporation, transpiration, evapotranspiration, infiltration, percolation, overland flow and surface runoff. Now let us see the individual definitions of all the terms. First of all, precipitation, it includes rain, snow and other forms of water falling from the atmosphere into the land and oceans. Evaporation, physical process by which water is evaporized or vaporized into the atmosphere from free water surface and land areas. Component is transpiration. Water from the soil is absorbed by plant roots and eventually discharged into the atmosphere through little pores in the leaves called the stomata. Evapotranspiration is the culmination of basically two words, evaporation and transpiration, combined process by which water is transferred to the atmosphere from open water surface and vegetation. Infiltration, movement of water from the land surface to the upper layer of the soils. Percolation is the movement of water through the subsurface down to the water table. Overland flow is the portion of runoff that travels over the surface of ground to reach a stream channel. And finally, the subsurface runoff, or basically called as surface runoff, includes all overland flow as well as precipitation falling directly into stream channels. Now the water which is coming onto the surface in terms of precipitation has different forms. So while defining the forms of precipitation, there are different forms. First one is the drizzle, a light steady rain in fine drops of size around 0.5 mm and intensity which is less than 1 mm per hour is called as the drizzle. Second one is the rain, the condensed water vapors of the atmosphere falling in drops. If the size is greater than 0.5 mm and the maximum size is around 6 mm and the clouds. Next one is the glaze. Glaze is the freezing of drizzle or rain when they come in contact with the cold objects. Next is sleet, frozen raindrops while falling through air at sub-freezing temperature. Next is snow, ice crystals resulting from sublimation, that is the water vapor condenses to ice. Next is hail, is the small lumps of ice having diameter size greater than 5 mm formed by alternate freezing and melting when they are carried up and down in highly turbulent air currents. Dew, moisture condensed from the atmosphere in small drops upon cooling surfaces. Frost, a feathery deposit of ice formed on the ground or on the surface of exposed objects by dew. Next is fog, a thin cloud of varying size formed at the surface of the earth by condensation of atmospheric pressure. Last but not the least, the mist, a very thin fog. We have already seen the forms of precipitation. Now the precipitation can also be classified in terms of their types. First one is the conventional precipitation. It results from the heating of Earth's surface. Due to this, the warm air rises rapidly into the atmosphere. As the air rises, it cools. Water vapors in the air condenses into clouds and precipitates. Next one is the orographic precipitation. It results when warm, moist air moving across the ocean is formed to rise by large mountains. As the air mass rises, it cools. As air cools, the water vapors in the air condenses and water droplets are formed. Precipitation occurs onto the windward side of the mountains. The air is now dry and rises over top the mountain. As the air moves back the mountain, it collects moisture from the ground via evaporation. Last one is the cyclonic precipitation, also called as the frontal precipitation, which results when the leading edge of the warm moist air mass collides with the cold mass. As we can see in the diagram, the conventional precipitation, orographic precipitation, and the frontal precipitation. Or conventional precipitation is the one when the moist air mass comes in contact with the hot surface. The air mass get lightened and it rises upwards. As it moves upward due to the height difference or the temperature difference, the air mass get cooled and the vapor present in the clouds are condensed and the precipitation happens. Same phenomena is happening in the orographic precipitation. The warm, moist wind is having certain amount of water present into the clouds. As it comes in contact with a mountain or any obstruction, the air mass rises. As it rises, the temperature decreases and the water which is present into the clouds condenses and comes down in form of the precipitation. Last one is the frontal precipitation when two air mass, one hot air mass and second one is called cold air mass, interact with each other. The tendency of cold air mass is having the higher density comes under the hot air mass, and as soon as the hot air mass increase, the size or the depth of the hot air mass increases, the temperature decreases because of the height difference, and the precipitation happens because of that. Thank you so much.